I'm here at the Hy-Vee in Mankato to see if these employees really are the best at keeping their store organized and orderly. To test the theory, I'm going to be placing an orange in the apple section of the produce department. Our super secret spy cameras will capture the action, and we'll see how long it takes for them to find the orange. Timing will begin at the moment that I place the orange in the apple section. We'll see how long it takes for an employee to notice and put the orange back in the correct spot. Oh, that was really fast. I hope I can get a refund on these super secret spy cameras. Okay, so in this video we're going to be learning how to combine like terms. This is very useful for when you have big, annoying polynomials like this one. We can make them nice and small, like this green one here, by combining like terms. So let's just take a look at this example. We're just going to practice identifying like terms. So we're looking for things that have the same powers of x. Okay, so this 4x squared right here has a like term over here, 2x squared, because they both have the same powers of x. Those are like terms. Now I can find more like terms by looking through the polynomial again. So like right here we have a 2x, just underline that. Over here we have an x. Those are also like terms. Now when you're thinking about like terms, I want you to picture the produce department at Hy-Vee. Picture how each kind of fruit is in its own section. The green apples are together, the red apples are together, the plums are together. It's all, sectioned off. That's how like terms are supposed to be. So we're going to look at an example. Let's think about this polynomial. But before we get to the numbers, I want to think about it in terms of fruit. So I'm going to let these apples be x squared, let the oranges be x, the plums be numbers. So here's our equation. I'm just going to substitute all the x's and numbers for fruit. Alright, so we've got 2 oranges, 4 apples, 3 plums, 2 apples, and an orange. And now I'm going to combine like fruit. So just rearrange it so that they're all in their own separate spots. Now if we do this with numbers, it's kind of the same idea. Here's the equation, or the polynomial that we started with. Now instead of combining like fruit, I'm just going to combine like terms. So like these two, 2x and x, they're like terms. When I combine them, I get 3x. Combine these like terms and we get 6x squared, and that nothing happens to that 3, stays the same. Now technically we should write it with the biggest powers of x first. I'm just going to rearrange it. But notice how, just like the like fruits stayed together, the like terms stayed together in the problem. Okay, so let's try another example. First step, we have to identify the like terms. So we have this 3a squared b and a minus 4a squared b over here. Okay, now notice how I circled that minus. Do not forget to circle the minus. Okay, so that's because that's part of the term. We have this 2ab, and I spot another term, a like term to this over here, minus ab. And we have this 5. He's all by himself, no like terms for him. Okay, now that we've identified, it's time to combine. So remember how I rearranged the fruit so that they're all together with the same kinds of fruit. Now we're going to rearrange the numbers so they're with the same kinds of numbers. So 3a squared b and minus 4a squared b, we combine those, we get minus a squared b, because 3 minus 4, negative 1. Now let's combine these purple ones, 2ab and minus ab, we combine those and we'll get ab, because 2 plus minus 1 is 1. And this 5 just comes over here. 5's got nothing to combine with, he just stays the same. And that's our answer. So, in this video, we have learned how to identify like terms, and we have showed how to combine like terms. These are 2 skills you're going to be using in pretty much every math class you take from here on out.